Hello, everyone. Thanks, Rohan, for hosting the session. And thank you guys for joining the talk. My name is Stevan Milovanovic, and I'll give you a brief overview of animations with Jetpack Compose. So during this talk, we'll try to answer some questions. The main one is how to implement motion design. And to answer that one, we have to answer how to get from idea to implementation, and what are animation building blocks. So where to start? I would say start from these three questions. The first one, which property should you animate, when it should be animated, and how should we animate it? So let's try to dive into each of these. The first one, which property you can animate. Here are the options. So you can animate scale, rotation, alpha, color, or translation. And here you can see graphical representation for each of these. And sorry, just a second. Okay. And yeah, we saw which properties we can animate, and let's now check how we can access these properties. And the answer is through graphics layer modifier. Here you can see an example animation where we animate the alpha of this text composable, and you can see that we defined the state and we are changing that state inside of the graphics layer. So this is how you would implement animation from the scratch. And as you can imagine, it can be as complex and as customizable as you want. And what's great about graphics layer modifier is that it runs in the draw phase of the compose, which means that any animation change won't trigger a recomposition. So yeah, this is the right place where you should do all the property changes. The second question we have to answer is when should we change our property? And here also we have a couple of possibilities. The first one is on state change. So as we saw previously, you can animate your property on some state change. Other option is to animate it on the launched effect. Another option is you can also animate some component infinitely. And the last option is to animate it with some gesture. So for example, today we will show how to animate something, some view with the dragging gesture. Again, let's dive into each of these to figure out what are the possibilities. The first one on state change. So this API is designed to store and manage the value over time, and it's typically used for one-shot changes by using this animate as state API, and you can see what you can animate. So you can animate color, rectangle, size, float, as we did for the alpha or density pixels. And let's dive into example. So here you will see that we implemented the exact same animation we did on the start with the graphics layer. But here we avoided using graphics layer directly by using animate float as state API, in which we are changing our state, and afterwards we can assign that directly to the alpha modifier. On the right side, you can see that the result is the same. What else we can do with the on-state change API? We can define a transition, and transition assumes coordinated state updates as written here. What that means? It means that the changes will happen at the same time based on the state, and they are dependent on each other, which means that they will happen at the same time. As you can see on the right side, this animation is composed of three animations. So we are animating two properties on a text composable and one property on its container on this box composable. So as you can see, we combined here two components and three properties. So this can be used to implement some pretty complex animations. Okay, we covered the onState change API, and the next possibility, as we said, is to trigger the animation on launch. And here we use the launched effect, and to define the state, we used animatable concept, and that's just a value holder that automatically animates its value when the value is changed through the animate2 method. And here you can also see that by using animatable, we again avoided using graphics layer. So now we can use directly that state to assign it to a modifier. And here you can see how that animation looks. So basically, it's most commonly used to start some animation right after composable is composed. The next possibility is infinite animations, as its name says. It runs forever, and here is how we define it. So we have to again declare a transition, and we can add our animations to that transition. And what are you seeing here? That we are using something which is called animation spec. We still didn't explain that concept, so remember it for now, and we will explain this later in depth. And the last possibility for when to trigger our animation is with some gesture. So these are called gesture-based animations. And for these, there are some principles which should be respected. The first one is they need to be interruptible when the touch begins. And the second one is they need to continue after the gesture is finished by either decaying or snapping to a certain position in order to feel like a natural stop. In this initial implementation, which you can see on the left side, you can see that we defined a draggable state, and we used that draggable state to assign it to a draggable modifier, which makes our view draggable. And in the graphics layer, we define how we actually want to animate our view. So we have some translation on the y-axis, and we have some scaling using the linear interpolation. But what's wrong with this animation is that it doesn't respect the second principle we mentioned. So as you can see, it can end up in any state, and that makes it feel a bit odd. So let's improve it. How can we improve it? By handling the fling gesture. And what should happen after the user lifts their finger is called the fling gesture. So again, to make animation more natural, we have to finish animation after the gesture is finished uh, to end up in some of the defined final state to make animation more natural. And you can see here how we did it. So firstly, we defined the decay, and then we added to our draggable modifier on drag stop property, which will provide us a velocity. This velocity, alongside with the translation y, will be used to calculate target value for a decay. And based on our threshold values, we can calculate if we can reach the target with the decay. If we can, we will continue decaying to a target value. Otherwise, we will animate to like a starting position or the initial state. And as you can see here, we defined two final states. The first one is full size of this screen, and the other one is minimized screen. So if you pay attention to the animation on the right side, you can see that it can end up only in these two states. So there are no states in between anymore. Okay, so uh, we answered also the second question, when we can animate our property. So there is only one more question, and that's how should we animate our property? And that's defined by an animation spec. That's the concept I already mentioned. And here we have some uh, currently supported animation specs. The first one is tween, that's shortened from between, and this will just animate between two values. This animation spec accepts three parameters. The first one is duration, the second one is delay, and the third one is easing curve, which I'll explain later. But what's important to mention that this is duration-based animation spec. The next one is snap. That one is pretty straightforward. It immediately switches the value to the target value. It's also duration-based animation spec, but duration there is 0 since it immediately changes the value. And the last duration-based animation spec is keyframes spec, which animates based on the snapshot values. It's similar to tween animation, but it gives you more control over the animation. The next one is repeatable animation spec. This one accepts uh, animation as a property, and that has to be duration-based animation spec. It accepts animation spec, which has to be duration-based, and the second parameter is count, which represents basically the number of repetitions. And again, as opposed to this repeatable, there is infinite repeatable, which we already used to define infinite animation. And the last one is Spring. Spring creates a physics-based animation, and that's default animation spec for most of animations. And for example, it can handle interruptions more smoothly than duration-based animations. And let's check the example I already mentioned. So if you look at the animation on the right side, that was the animation we already defined previously when we explained infinite animation. So let's see what we actually used there. So as I said, we used infinite repeatable spec. And as you can see here, it accepts duration-based animation spec. And for that, we used tween animation spec, where we defined the duration. We didn't define the delay, which means we will use the default value, which is without a delay. And lastly, it accepts easing. That's easing curve that will be used to interpolate values between start and end. The default value is fast out, slow in easing. The most basic one is linear easing, but there are like a bunch of options there. And yeah, with this, we answered these three questions. So now we know what are the building blocks for animations and what's further. So you can explore built-in animation APIs. And as you can see here, there are like a bunch of them. I mentioned just a few, which we will try to show. So let's show how animated visibility container is used. So you just have to wrap your component and to provide a state based on which this visibility is changed. And as you can see on the right side, it seems really natural. So we avoided all the hard work with this built-in API, which is great because this is probably the most common used animation in any app. And the second one I wanted to show you is animate content size modifier, which is also convenient when you have some collapsed and expanded state, as I wanted to show here. So what you have to do is just add this modifier, make sure to add it before you add height and width modifiers, and yeah, everything works out of the box. And it looks pretty cool. You can also customize it as you want. So yeah, again, for these built-in animation APIs, there are like a bunch of options. I invite you to explore them, and once you dive into them, you will see that there is also a decision tree to decide which animation API to use based on your animation requirements. And yeah, it's pretty helpful. It will help you to get the answer on all of these questions. And yeah, I think I covered everything. So the summary, what I would like you to take away from this presentation and what I would be happy for you to remember is the first thing, analyze animation with three questions in mind. So it will help you to realize which API to use and how to implement your animation. Hopefully, you will be able to use some of the built-in APIs. If that's not the case, graphics layer is your friend, so you can always use that and implement your animation from scratch. Um, And yeah, I want to stress again to explore all the built-in components because for most of the use cases, they can give you a shortcut. Lastly, I want to thank to Rebecca, which made this great video, which was basically the inspiration for me to make this talk. So if you found something unclear during my talk, make sure to check out her video and everything will become clear, I'm sure. And yeah, I think I covered everything. This is my handle. Make sure to scan this link if you want to reach out. And yeah, feel free to reach out if I can help you anyhow. I'm more than eager to answer all your questions. Thank you for listening.
Thank you, Stevan, for presenting the topics of the animation. I really like the part where you beginning like the three questions, which I find missing on all the animation documents. This thing really helped us to question when to animate, which part to animate. This thing I think will be really helpful for our viewers as well. Thank you, Steven, for that.
Thanks.
We can have Q&A. I guess we have time. So yeah, let's see if we have any questions as of right now. Okay, I think we don't have any questions. So yeah, again, thank you, Steven. Very grateful talk, insightful talk, and we are very glad to have you here on the annual one.
Thanks, Rohan, for the feedback. Yeah, I try to provide an example for each concept because I find it much more easier to understand when there is like a visual representation, especially for animation. It was a bit hard to prepare the animation, but hopefully it was in good resolution. Yeah, I guess I'll see that once the recording is ready.
Yeah, yeah, definitely. The animation I see like it was like the animation is something which is visual and it should be shown as a visual thing only. So yeah, definitely we were able to relate as well you were speaking. So that was a very good thing. We have one questions uh, from Babu. Can you like are animations on graphically or hardware accelerated? Steven, can you answer that?
Yeah, I see the question, and thank you, Babu, for the feedback. But regarding the question, I have to admit that I'm not sure. I can check that and get back to you, but I'm not sure what's actual internal implementation. I didn't dive that deep.
Okay. Yeah. Okay. Yeah. Thanks, everyone. Very glad to have you here.
Thank you very much.